So in the last class, we already discussed about the properties of jet transforms. Okay, so here the properties of jet transforms are linearity property, time shifting property, frequency shifting property. Okay, like Laplace transform, frequency shifting property, time reversal property. Okay, convolution property, differentiation in jet domain. Okay, next initial scaling in Z domain, initial value theorem, and final value theorem. Okay, so next we will solve the problems. Okay, find the jet transform of x of n is equal to 1 by 2 whole power n into u of n minus u of n minus 10. Okay, for this we have to find the jet transform. Jet transform of x of n is equal to jet transform of 1 by 2 into whole power n u of n minus u of n minus 10. So it is equal to jet transform of 1 by 2 whole power n into u of n minus jet transform of 1 by 2 whole power n into u of n minus n. So if we take 1 by 2 whole power n into u of n, jet transform of this one is jet by jet minus 1 by 2. That is here ROC is not jet is greater than 1 by 2. Next, using the shifting property, bit difference shifting property, u of n, jet transform u of n is u of z, then jet transform u of n minus k is z power minus k into u of z. Similarly, u of jet transform u of n minus 10 is z power minus 10 into u of z. Okay, so x of z will become 2 into this is z by z minus 1 by 2 minus minus z power minus 10 into u of z. Okay. So it is 2 into z power 10 minus 1 by 2 whole power 9 by z power 9 into 2z minus 1. Here ROC is not z is greater than 1 by 2. This is about the z transforms and its properties. Right now coming to the inverse z transform. Inverse z transform, like inverse Laplace transform, we have also inverse z transform. So as we already know that the z transform of x of n is x of z, that is called z transform. Then the inverse z transform is nothing but the transform of x of z is nothing but x of n. Okay, so x of n equal to inverse z transform of x of z. Right. So now we have three methods to find x of n. So here inverse z transform methods are three methods. So first one is power series method, or it is also called as long division method. Next, partial fraction method, and third one is residue method. First one is power series method or long division method. Second one is partial fraction method and residue method. First one is the power series method or long division method. It is very simple method, from childhood onwards we learned this power series method or the long division method. So we'll solve a problem so that we can understand the long division method concept or power series method concept. Okay, given that x of z is 1 by 1 minus z power minus 1. 1 by 1 minus z power minus 1. Here ROC is mod z is greater than 1. So x of z equal to 1 by 1 minus z power minus 1. Right? So by long division method, we will do like this 1 by 1 minus z power minus 1. So by multiplying 1 into 1, 1 minus z power minus 1. So that by subtracting this, we will get 0 plus z power minus 1. Then 1 into z power minus 1, that is z power minus 1 minus z power minus 2. So by subtracting this, will get cancelled and this will become z power minus 2. And this will be multiplied by z power minus 2. So z power minus 2 minus z power minus 3 like this and so on. So it will become 1 plus z power minus 1 plus z power minus 2 plus z power minus 3 up to z power minus 7. That is taken as equation number 1. But as for the definition of the z transform is concerned, x of z is x of 0 into z power 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 plus x of n into z power minus n. By this is equation number 2. By comparing these 1 and 2 equations, so here x of 0 value is 1, x of 1 value is 1, x of 2 value is also 1, x of 3 value is also 1. So all these values are 1. So x of n is also 1. So we can say that x of n equal to 1 for n is greater than or equal to 0, or x of n equal to 1 means u of n. That is the power series method or long division method, inverse jet transform, one method of inverse jet transform, that is power series method or long division method. Okay, right. Next, similarly, we can solve these problems x of z equal to 1 by 1 minus a into z power minus 1. That is, its solution is x of n equal to a power n into u of n. Similarly, x of z equal to 1 by 1 plus a into z power minus 1. So its solution is x of n equal to minus a power minus n into u of minus n minus 1, right? Okay, right. So similarly, next problem is calculate x of n using long division method. Calculate x of n using long division method. So x of z is given as z square plus z by z cube minus 3z 4 minus 2 plus 3z minus 1. Okay. Here ROC is mod z is greater than 1. So z square plus z and z cube plus minus 3z square plus 3z minus 1. So by multiplying z cube with z power minus 1, we will get z square. Okay, so this z power minus 1 will be multiplied with this entire terms, so that it will become z square minus 3z power 1 plus 3z power 0, okay, minus z power minus 1. So that we will get 4z minus 3z power 0 plus z power minus 1. Z power 0 is 1. Okay, so then how to get 4z by multiplying z cube with 4 into z power minus 2. So that we will get the terms like this. Like this will do, so that we will get x of z is equal to x of 0 plus z power minus 1 plus 4 into z power minus 2 plus 9 into z power minus 3 plus 16 into z power minus 4 and so on. So here x of 0 is 1. So x of 1 is 1. X of 2 is 4. X of 3 is 9. X of 4 is 16. So 1, 2 square, 3 square, 4 square. Like that n square. So x of n is n square per n is greater than or equal to 0. Or we can say that x of n is n square into 1. That is n square into u of n. So that is the first method, the power series method or long division method. And the second method is partial fraction expansion method, PFE. This is also called as PFE, partial fraction expansion method. So we will do a problem x of z equal to 10z by z minus 1 into z minus 2. Okay, x of z equal to 10z by z minus 1 into z minus 2. Right. So we can write this as x of z by z equal to 10 by z minus 1 into z minus 2. Okay, 10 by z minus 1 into z minus 2. Right. Then 10 x of z by z equal 10 by z minus 1 and z minus 2. So we can write this as a by z minus 1 plus b by z minus 2. A and b can be calculated as a equal to 10 by z minus 1 and z minus 2 into z minus 1 by keeping z equal to 1, so that it will become minus 10. Similarly, b equal to 10 by z minus 1 and z minus 2 into z minus 2 by keeping z equal to 2, that is 10. Okay, so b is also 10. So by simply substituting the a and b values in that expression, so that x of z by z is equal to minus 10 by z minus 1 plus 10 by z minus 2. Okay, so r by cross multiplying, x of z will become minus 10z by z minus 1 plus 10z by z minus 2, or by taking 10 as common, 10 into minus z by z minus 1 plus z by z minus 2. Okay, so we can write this as a 10 into minus 1 by 1 minus z power minus 1 plus 1 by 1 minus 2 z power minus 1, or 1 by 1 minus z power minus 1 is nothing but 1 plus 1 by 1 minus 2z power minus 1 is nothing but 2 power n. So it is 10 into minus 1 plus 2 power n. So x of n is 10 into minus 1 plus 2 power n into u of n. Okay. So determine x of n using partial fraction expansion method. This is another problem, that is x of z equal to 2z square by z plus 1 into z plus 2 whole square. We can write this as xz by x is equal to 2z by z plus 1 into z plus 2 whole square, or we can write this as a by z plus 1 plus b by z plus 2 plus c by z plus 2 whole square. So a can be calculated as z plus 1 into 2z by z plus 1 into z plus 2 whole square by keeping z equal to minus 1 by simply substituting z equal to minus 1 in that expression, so that we will get a value is minus 2. Okay. Similarly, how to get b value? B equal d by dz of z plus 2 whole square into 2z by z plus 1 into z plus 2 whole square by keeping z equal to minus 2. Okay, d by dz of 2z by z plus 1. So this is in the form of u by d formula. So u square into u into d by d of v minus v into d by d of u. Okay, by simply substituting and substitute the value of by simply solving and substitute the value of z equal to minus 2, will get the value of b is 2. And similarly, c equal to z plus 2 whole square into 2z by z plus 1 into z plus 2 whole square by keeping z equal to minus 2. Okay, it is equal to 2 into minus 2 by minus 2 plus 1. So it is 4. Is 4. Okay, so then x of z by z equal to minus 2 by z plus 1 plus 2 by z plus 2 plus 4 by z plus 2 whole square. Or we can write this as x of z equal to minus 2z by z plus 1 plus 2z by z plus 2 plus 4z by z plus 2 whole square. So z transform a for n into u of n is nothing but z by z minus a. Similarly, z transform n into a for n into u of n is nothing but az by z minus a whole square. So minus 1 whole power n. Z transform minus 1 whole power n is nothing but z by z plus 1. Similarly, z transform minus 2 whole power n is nothing but z by z plus 2. N into minus 2 whole power n is nothing but minus 2z by z plus 2 whole square. So taking inverse z transform on both sides, we get inverse z transform of x of z equal to 2 into inverse z transform of inverse z transform of z into 2 into inverse z transform of z by z plus 1 plus 2 into inverse z transform of z by z plus 2 minus 2 into z transform of inverse z transform of 2z by z plus 2 whole square, so that it will become minus 2 into minus 1 whole power n plus 2 into minus 1 minus 2n into minus 2 whole power n plus but n is greater than or equal to 0. So it is sub n is 2 into minus 1 whole power n plus minus 2 into whole power n minus n into minus 2 whole power n into u of n. So that is the second method, partial fraction method. And third one is residue method, or it is also called as inverse integral method. Residue method or inverse integral method. Okay, so x of z is given as 10z by z minus 1 by z minus 2. The discrete time sequence x of n can be obtained from its z transform by using inverse integral. Inverse integral is that is x of n is equal to 1 by 2 pi into integral x of z into z power n minus 1 into dz. This is inverse integral. X of n equal to 1 by 2 pi j into integral x of z into z power minus z power n minus 1 dz. Okay. Right. Let x of z into z power n minus 1 be g of z, so that it will become x of n equal to 1 by 2 pi j into integral g of z into dz. That is nothing but sum of residues of gz corresponding to poles of g of z. Okay, sum of residues of g of z corresponding to poles of g of z. Right. So x of z will become 10 into is given as x of z equal to 10 z by z minus 1 into z minus 2. So g of z is nothing but x of z into z power n minus 1. So what is x of z given? 10 z by z minus 1 into z minus 2 into z power n minus 1. Okay. So that it will become 10 into z power n by z minus 1 into z minus 2. So g of z contains whole set z equal to 1 and z equal to 2. Therefore, x of n is obtained as a residue of g of z at z equal to 1 plus residue of g of z at z equal to 2 at 2 poles. Okay. So residue of g of z at z equal to 1 and residue of g of z at z equal to 2. So that is residue of g of z is nothing but r at z equal to 1 plus r at z equal to 2. So for r equal to r at z equal to a, it can be obtained as z minus a into g of z at z equal to a. Similarly, z minus 1 into g of z at z equal to 1 is nothing but z minus 1 into 10 into z power n by z minus 1 and z minus 2 at z equal to 1 is nothing but n into 1 power n by 1, that is minus 10. Similarly, residue at z equal to 2 is obtained as z minus 2 into g of z at z equal to 2. So z minus 2 into 10 into z power n by z minus 1 into z minus 2 at z equal to, that is 10 into 2 power n. So x of n equal residue at z equal to 1 and residue at z equal to 2. So that is minus 10 plus 10 into 2 power n for n is greater than or equal to. So therefore x of n equal to, taking 10 as common, 2 power n minus 1 into u of n. The next problem is x of z is equal to 3z minus 1 into z by 2 into z minus 1 whole cube. Okay. 3z minus 1 into z by 2 into z minus 1 whole cube. So x of n, how to get x of n? 1 by 2 pi j integral x of z into z power n minus 1 into dz. Right? Minus 1 dz. Okay. Right. Let x of z into z power minus 1 is g of z like this. Z power minus x of z into z power minus 1 is nothing but z power n minus 1 is nothing but g of z. Here also x of z into z power n minus 1 is equal to g of z, so that it will become 1 by 2 pi j integral g of z dz, that is the sum of residues of g of z corresponding to poles of g of z. So x of z is given as 3z minus 1 into z by 2 into z minus 1 whole cube, or g of z equal to x of z into z power n minus 1. So g of z equal to 3z minus 1 into z by 2 into z minus 1 whole cube into z power n minus 1. Okay. So it will become 3z minus 1 into z power n by 2 into z minus 1 whole cube. Right. So that by multiplying this, it will become 3 into z power n plus 1 minus z power n by 2 into z minus 1 whole cube. So it is the g of z containing, it is a third order whole at z equal to 1. So this is z minus 1 whole cube, that is third order whole at z equal to 1. Now x of n equal to residue of g of z at z equal to 1, third order whole. So x of n equal to r residue at z equal to 1, third order whole. So for in general for nth order whole, the residue at z equal to a can be calculated as d power n minus 1 by dz power m minus 1 into z minus a whole power m by m minus 1 factorial into G of Z at Z equal to A for mth order code. Here it is third order code, then it will become d power 3 minus 1 by dz power 3 minus 1 into z minus a whole power 3 by 3 minus 1 factorial into G of Z at Z equal to A, right? So it is here Z is given as 1. So it will become d square by dz square of z minus a whole cube by 2 factorial into G of Z at Z equal to A. So G of Z is this one. So z minus 1 whole cube and z minus 1 whole cube gets cancelled. So that it will become d square by dz square of 1 by 2 into 1 by 2 factor 1 into 2 1 by 4 into 3 z4 n plus 1 minus z4 and at z equal to 1. So substitute z value is 1. So 1 by 4 into 3n into n plus 1 whole power 1 power n minus 1 minus n square minus n into 1 power n minus 2. So it is 1 by 4 into 2n square plus 4n. So it is 0.5 n square plus n. So therefore x of n equal to 0.5 n square plus n, or n is greater than or equal to 0, or x of n is equal to 0.5 n square plus n into u of n. Okay. This is the residue method or inverse integral method. So these are the three methods in this one. Okay. And these are some problems related to the transform. Okay. A4 m into Z4 minus n is already solved. This was also solved. Okay. This the Z transforms and inverse Z transforms, the properties. Okay. And ROC, everything was discussed there, right? Okay. With this, I am concluding this class. Tomorrow I will continue in the next class.